Okay, guys, continuing on with Friday's assignment that I posted towards the end of class, Newton's second law, part 2, practice problems. Okay, we're going to be needing to know a couple different things here. If an object is on a surface, flat surface, once you know what its weight is, Fg, F sub g, all right, which is mass times gravity, we're using 10 for gravity. The normal force is going to be the same value. So that's why I have F normal is weight equal to weight. F net is going to give us an object's mass times acceleration. Now, if we draw a free body diagram, we can determine what the net force is. And if we know the mass, we can then solve for acceleration. All right, a lot of these problems, guys, you're going to wind up getting or having 2 of the 3 needed to solve for basically one of these 2 equations. But to do that first, essentially, you're going to need to do this step and this step. Now, if they gave you the weight of something in newtons, if they said, hey, you have a 400 Newton box, and then they wanted you to solve for the net force, well, dividing by 10 would give us mass that we could use in this equation here. So these were the 2 that we had completed on Friday. So for number 3, let's take a look here. Let's see, we got 1.5 kilogram block being pulled across a horizontal surface that has a coefficient of kinetic friction of 0.6. Now it's a unitless number, so that one is the only thing that you don't need a unit for. All right, that's that little Greek symbol mu. So actually I'm going to go up and I'm going to click in here and I'm going to highlight that piece, Control C, and I'm going to bring it down. I'm just going to put it right next to it because that way I know what the hell it is. All right, now they want to know what the friction force is, or what is the friction force exerted by the surface on the block. Okay, so what do they want? Friction. So from the problem like above, if we work that out, this is what I'm looking to solve for. Okay, right off rip, I have mu. I have my coefficient, which would be this 0.6 instead of 0.8. I need normal force. How do I find normal force? Well, if you're given mass, to find weight, F sub g, it's equal to mass times gravity, just like this up here. So I'm gonna just highlight that, copy it, and flop it, and then drag it down here. Create a second text box. So the object's mass was 1.5 times it by 10, and that is going to give me an F sub g. My weight is equal to 15 newtons. So if my weight is 15 newtons, guys, what about the normal force? If weight down, all right, so we have F sub g down here, and we have F sub n for normal force. These 2 things, guys, are equal. So if these 2 forces are equal, they have to balance each other. So if the weight is 15 newtons, that means the normal force has to be 15 newtons. So we have our F sub n for normal force, and that is equal to 15 newtons. And now we have everything that we need. We have our 0.6 here. times 15. That is not a 15. That is, okay, there we go. And we're going to get an answer here of friction force is equal to 9 newtons. So guys, now that we have the force of friction is 9, I'm going to just put that, I'm going to draw that in on the diagram because I think that just is going to help us for a second. So I'm going to just draw a little arrow over here and I'm going to just add in via text box friction force equals 9 newtons. All right, I don't really need to worry about the Fn currently and F sub g because I know those two things are equal. So they're not going to wind up affecting our net force because they balance out each other already, and it may not help or affect our acceleration. Because in part B, they said if the block was pulled by a 12 Newton force, what is the net force on the block? So that is basically saying we have a, actually I don't want to do that in black, or in red, let's go back to black, excuse me. Thank you. All right, and we have an applied force here, F applied, and that is equal to 12 newtons. So by looking at the drawing, sorry that it's a little crowded, actually I can scoot this over. What would my net force on this object be, guys? Just by looking at the drawing. Good. All right, basically if we had to just have one tiny drawing here, it would be, you don't need to make this drawing right here, this last little piece. All right, so that would make your F net what? Good. 3 newtons to the right. So we don't really need to do much here. We can just say same thing.
Do we have to write that F net?
No, you don't. You don't have to if you don't want to, but I'm writing it for now. You need it for at least part B. So we know that the net force here, guys, is 3. How do we know? Well, you have two vectors, opposite directions. What do we do with them? We subtract. So you have 12 to the right. You have 3 to the left. So our net force would be 3 newtons to the right. Remember from last week, the accelerations have to go in the direction of our net force. So the fact that we have our net force going to the right, that is telling us our acceleration is going to be to the right if we have an acceleration. Oh snap! We have to find acceleration. That's what they want here. So what is the acceleration of the block A? So F net is equal to m times A. Or if I'm looking at this triangle, if I want to solve for A, if I covered A up, it's F net over M. So I'm going to go back. A is equal to F net divided by mass. Do I have everybody? I do. Which would be 3 newtons divided by, what was the mass of the object? Scoot back up, 1.5 kilograms. And that leaves us with an acceleration of 2? That makes sense. Yes, it does. Meters per second squared is our final answer.
Miss Lombardo.
Is everybody good to go?
Yeah.
All right. Now for number 4, 4 is kind of a simpler problem. They give us a mass. They tell us that it's being pulled with across a horizontal surface by a 15 Newton force at, this is a kind of a big term right here, this constant velocity. I'm just going to underline that. Why is that important? Anyone? Anybody? Anybody remember? You should. All right, anytime you have something at rest or with a constant velocity, that means you have a net force of 0. That is not a 0, that was an O. That is not a, Jesus, okay. So that's cool. All right, that's great. Now, I'm gonna just scoot up for a second. I'm just gonna basically copy this piece here. And I'm gonna scoot down. All right, so in this case, our mass was 2. 2 times 10 is going to give us a weight of 20 newtons. So since weight is mass times gravity, we have a weight of 20 newtons. So with that, right, we have F sub G. Just going over here to highlight this because I don't feel like doing that. F sub N. What else is true about this? Well, these things are equal. Again. So they also tell us that we're getting pulled to the right with a force of 15 newtons. All right, we have an applied force of 15 newtons to the right. But they said constant velocity is 0. So you guys, when you see that in a problem, you have to understand the net force has got to be equal to 0. Because that is a very kind of, that's almost as important as having a number, right? Like 15, all right, I need to use a 15 somewhere. The 2 kilograms, okay, that's a good. Constant velocity is almost as good as a number because it's telling you, hey, it actually does essentially give us a number because we have a pull or applied force of 15 newtons. We're just going to say it's going to the right. Oof, that is atrocious looking. So we got 15 newtons to the right. So if the net force is 0, what would the friction force have to be going to the left? Good, 15. Oh, that was, why did it? Bam. F sub F, that would be 15 as well. All right, this guy here is our applied force. So the net force, just because they said we're at constant velocity, that right off rip is telling me this piece here, F net is 0. So I'm just going to copy that, paste it down here. And because we haven't had to do essentially we hadn't had to do any math yet. I just did this solve for the weight thing because I figured we may need it in a second. But to solve for the net force, didn't need that. we didn't need to do any math here. What is the friction force? Didn't really need to do any math as long as you understand that constant velocity means net force is 0. So if I was pulling with 200 newtons to the right, what would the friction force be? 200. So what is the friction force here? It's 15 newtons. It's 15 newtons. And then part C wants to know what the coefficient of friction is between the block and surface. Okay, so if we know that the weight is 20 newtons, what does that mean our normal force is going to be if normal force and weight are the same? Good, okay, so we're going to need that. F sub n is equal to 20 newtons. I'm just going to recopy this friction thing again because why the hell not? We're going to use that as well. And then I'm just going to go back up to the top real quick to grab the that other symbol, that other little symbol, the mu. This guy. So friction force is equal to the coefficient of friction times the normal force. So if I want to get mu by itself, I mean, I could rearrange it or I could just do this. Actually, I'm just going to show it like this. So that would mean we have 20 is equal to mu times 15. How do I get mu by itself? Divide both sides by 15. God bless you. Thank you. 1.33 repeating, and this doesn't have a unit. This guy here does not have a unit, so you're good with that. What did I mess up? I just caught myself. So this is the equation. Yep.
Net force because the Fn is 1520.
Good. So friction force should have been 15, and the normal force should have been 20. From over here, right? So the weight was 20, we figured, and weight and normal force have to be the same. So we should have 20 as our normal force. And in the equation, it's F sub F is equal to mu times normal force. So I accidentally flipped the numbers, and there we go. Hey, you know what? That's fine because that number seemed a little high. All right, a lot of the times, I don't want to say all the time, but there's a decent amount of times where the coefficient is usually just a decimal. There are times, don't get me wrong, where it can be like this, but just wanted to, like, something just seemed a tiny bit off, so I just wanted to recheck, and glad I did because caught my mistake. So it should be 15 divided by 20 or 0.75 as our final answer. All right, so we're going to stop here at 4. All right, we're going to stop at 4. So like I said in the beginning, you're going to have to probably use one of these two equations. So if you're given mass, find weight. And weight is going to equal normal force pretty much in 98% of these problems. So that's great because then that gives you this piece here. If you're given this, then you can solve for friction force. They may give you the pull force, push force, or the applied force. And then with the free body diagram, you can solve for the net force. And then from the net force, all right, you can usually use that to help solve for either mass or acceleration, whatever is going to be needed to do. Okay, so a lot of these times, a lot of the steps, guys, they're usually like 2 steps. They're usually, that's it. It's 2 steps. So it's just very important to understand the concepts. Okay, if you're given mass, and okay, mass, Gravity's always acting. I can find weight on a flat horizontal surface. Weight is going to equal normal force, which I need to use in the friction equation. You're going to have to be given like one of these two other pieces of information to solve for the missing, and then eventually that can help you get two of the three you need here to solve. So it's going to be like some sort of combination of those things going on. All right, but I'm going to stop. We're going to stop here at 4. These guys are similar problems, but there's other things that I want to get to today. Okay.